Okay, so we're going to continue to talk about the second law, and this is probably the final message to, to describe the spontaneous process in terms of using the entropy, which is not so widely used, but in a historical sense has to be covered. And this is what is called inequality, uh, Clasius inequality. So inequality means this, right? That's an inequality. And what we mean by this is for entropy change has to be Q over T. That's, I think, the Clasius inequality, the statement. So the main difference is, you recall this, probably the most useful one, and which is, we want to get back to you on this, is Q reversible over temperature, and that's the useful one. For any heat, that has to be, if it is a spontaneous process, entropy change is bigger than Q over T, and it can be proved by this. So that's Clasius inequality. And one thing that you know is work reversible, and if you think about any works, their magnitude is always bigger than that. And starting from this idea, this concept has come about. If I have that, and so therefore work minus work reversible is always is bigger than zero, because regardless of the sign, they should have the same sign, whether expansion is all the negative or positive or the compression. They always hold this one true. And my starting point is my starting first law of thermodynamics, dq plus dw. And then I can say, okay, dq reversible, dw reversible. So using this relationship, I can kind of carry on this inequality that we already know. The work on the reversible process is bigger than work on any kinds of process, and then using this relationship, I can change that into the heat relationship, which is Q reversible minus Q is bigger than zero. And then what I do is I divide by temperature, and this becomes Ts. And then you will see this equation start to popping in. And so that's a Clasius inequality statement. So this is for any kinds of heat transaction. The heat on the reversible process is the maximum heat. So this is always a bigger term. So this is in a way, what this means is Q reversible divided by P. So that's always a bigger term than the other. Probably the most useful one is the spontaneous process. I think I talked about in the beginning. Is ds is and this one is ds total is bigger than zero. So this is a spontaneous process. The second form of Clasius inequality is this one, and if it is really spontaneous, which is an irreversible process, which is a directional, and that's a positive, and the total is zero for reversible process. And this equation turns out to be more useful, and this is a statement about the spontaneous process total entropy change is bigger than 0. So that's sort of the finishing up to dealing with entropy change and the reversible and irreversible process. So this is a spontaneous process, which is a direction for change. And that's the first form of this. And do you remember that I mentioned this? dg is smaller than that, and that's for the system. That's what we are going to essentially use mainly in the future. But historically, this one was covered by this.